15 or 20 minutes. So if you came expecting a really long talk, I'm sorry. So anyway, here we go. So Perl, like many languages, have patterns. Pretty much all languages have various patterns. And so a pattern is really just kind of a reusable solution for common problems that you find. And they're also kind of just a shared vocabulary for talking about programming, which is useful. Often I find it just provides kind of a name for something you've already been doing. You know, and of course there's also anti-patterns, which provide names for things you've already been doing as well. So one interesting thing is that patterns kind of become language features over time. So like object orientation was what? Yeah. This will probably make the code examples look really bad, but what the heck. So, you know, probably at 1.00 was a pattern for C programming, or, you know, maybe subroutines were a pattern for assembly programming. And now these things have become part of languages. There's a really cool article about this that MJD wrote at this URL, and I really recommend everybody read it, because I just thought it was really interesting. So one thing I also want to say is what patterns are not. There's a lot of kind of hyper enthusiasm for patterns out there among some programmers. Java programmers are particularly notorious for this. I sometimes get the impression that the programmers think, well, if I use a pattern, my code must be good. And there's really, that's not true. Using patterns it's not required. It doesn't make you a better programmer. It doesn't make your code better just because you used a pattern. It's better if you've improved the code and found a way to kind of organize it. But really, the pattern is a name for that organization. It's not some magic silver bullet. You know, occasionally you just get people who are like, we should use this pattern. And it just seems like they're really excited because they just read the patterns book. And they're like, I got to put some patterns in my code because that'll make me awesome. But that's not true. It doesn't make you awesome. And in a way, if you read MJD's article, one of the things he basically says is patterns are just a deficiency in programming languages. And the fact that you're doing the same thing over and over again is actually really a red flag. That said, you know, if you're using Perl, you're kind of stuck with where a Perl 5 is at to a certain degree. So, you know, it's worth knowing how to do some common tasks. So as I mentioned, this is the patterns book. It's sometimes called the Gang of Four book because it's got these 4 authors who are, you know, part of the communist revolution. So the examples use C++ and Smalltalk, which is kind of, I don't know, weird for me when I read it. This book isn't a Bible. So again, people just, they get way too excited about patterns. They're like, you know, I worship this book. No, it's an interesting book to read. You probably learn something, but you know, don't get too obsessed. So this is the first pattern I'm going to talk about. This is a very useful pattern, but it's also just a kind of gross pattern. It's called the Singleton. Really, all it is a global. It's just, but now you've given it a nice name, so you can use it. See, if you just use a global, people are like, why are you using a global? No, I'm not using a global. It's the Singleton pattern. See, so you can kind of put one over on someone. So you know, it's just a way to sneak some globals into your app. You know, globals are useful. I just have to admit it. The key thing, the reason you use it is you want to have an object of a certain class. You want to use it over and over in a lot of spots. You really just always want the same object. So various reasons to use it are, you know, let's say you want to synchronize access to a resource, for example, log files, and just kind of share the object that accesses them. Or you want to avoid repeating the construction of some sort of expensive object, like DBI handles are sometimes expensive depending on your database. Or maybe you want to centralize your configuration, so your app config. You just want to read the app config file once in your program, but you want to be able to get at the object which represents that config over and over. So really, you know, this is really weird. I've noticed this before. Okay, the background on the code on my screen is actually gray. But for some reason, when I use projectors, I'm sorry, I'm going to digress briefly about my laptop and projectors. Sometimes when I use projectors, the colors are really off. And if you look in the upper left, there's this artifact. And if anybody can help me figure out why this happens with my laptop and projectors under Linux, I would just be so happy, because I can never get it just to like come out exactly the way I want it. It kind of drives me nuts. Okay, back to the presentation. So a singleton, really, you could just hide it. You could just have your constructor be a singleton under the hood. Every time we call app logger new, it's actually just returning the same object. It makes it once and kind of caches it. Or you could use this module class singleton off CPAN. You can use subclasses, and it provides a constructor called instance for you that builds that in. So every time I call app logger instance, I'm getting the same object over and over. So again, as I said, it really is a global. So don't use it willy-nilly. Sorry, that's an expression that's really not useful here in Japan. Don't use it all the time. And really, it's best if you use it for objects that don't have state. If you're using it for objects that have state, then really you're going to have an action at a distance problem, which is exactly why we don't use globals. If you use it for something that's basically stateless, like a logging object where it's just kind of writing to a file, or a DBI handle or something like that, you're probably okay. And then there's kind of like, I find myself using this sort of thing a lot, which is sort of a singleton, where I kind of have multiple singletons, which is basically, maybe I have named objects. So I might have multiple DBI connections that are identified by name. I've also done things where I kind of do it by kind of look at the caller and kind of cache objects based on the caller. And so when one package calls me, I give it the same object over and over. And this kind of is blurring the line between what a singleton is and memoization. So I don't know what to call this, honestly. Pseudo singleton or memoize singleton or something like that. This is another pattern that I actually find pretty useful. You've used this pattern in APIs. You've used APIs which do this because it's just incredibly common. Basically, the factory pattern is when you want a subclass of some sort, but you don't know which one in advance. And as the API user, you just want to say, give me the right thing. But you don't know what the right thing is necessarily. So basically, what the factory does is decide which subclass you're going to get. And all the subclasses share a common API, so you don't even have to know, as the end user of the API, which subclass you got. It doesn't matter. And DBI is actually an example. When you call DBI connect, it looks at the string you give it for defining the connection and decides what type of subclass it's going to give you. DBD MySQL or DBD PostPG or whatever. And you don't really care that much because they all share a common API for getting data, for executing SQL and getting data back from the database. So here's an example, which is, let's say you just want to say, give me something that will let me lock files. So the factory class, we'll call it file locker. We call it new, call new and pass it this file. And it gives me back this locker object. And presumably the locker is some sort of subclass. And you don't really care which one it is. You just call lock for write, and it does its thing. And under the hood, there's all sorts of kind of different ways that this factory could be working. Maybe it looks at the OS and says, okay, well, if you're on Unix, I'm going to use POSIX semantics. If you're on Win32, I don't know what Win32 does. I hope I never have to find out. But presumably it's different because Windows is always different. Maybe it looks at the file type and says, okay, if you're like a regular text file, I'll use one system. If you're a Berkeley DB file, then I can use the Berkeley DB API for doing that. And really the key is you just don't care how that lock for write is implemented. As the end user of the API, it just kind of works. So it's kind of like a way of providing kind of a magic, do the thing I want to do without having to make the end user of the API think about it much. So yeah, I think I just said what the slide says. The idea is you allow for many implementations. Things just work for the API user. They don't have to worry about it. And so another pattern that's kind of similar to that is the strategy pattern. Again, you have many subclasses which provide the same API. but they have kind of different underlying implementations. Often, in this case, it's kind of different algorithms for doing the same thing. But the difference here from the factory pattern is the caller actually is going to decide which one they want. And a good example of this is if you've ever used TK, it has a whole bunch of algorithms for doing the layout of the UI. And they're called like TK Grid, TK Pack, TK Tiler. There's a whole bunch of them. And you just pick one, and then you tell it, OK, use this to do the layout. TK uses these layout classes, which all have the same API. But under the hood, they're going to actually do your layout differently. So it's kind of like the factory. It has the same API for those subclasses. But in this case, the end user of the API is going to decide which one they want. So this is good when you want to tell people, OK, I'm going to give you a lot of choices for how to do stuff, but I'm not smart enough to figure out which one you want to use. You decide, because you know your app better. Another case where you might do this is if you have different algorithms where one is optimized for speed and one is optimized for memory use, and you might tell the caller, OK, well, you know, I can't figure it out. You know your data better than me. Why don't you pick one? But they all will work the same. I keep doing, you know, after each one of these, I have a Y use X, and I keep saying it before I get to the slide. I hate when I do that. So this is another really common pattern I find myself using a lot called observer, which is basically where you have an object that listens to another object. And parsers are a really good example of where this can be useful. So when the parser encounters something that's of interest, it says, OK, I'm going to call a specific method on my observer. And potentially you could have multiple observers, so they could, you know, could call the method on a whole bunch of objects all at once, or one after another, not really all at once. So the Sax API is actually a good example. We could write an observer class called XML Sax Echo. And here's one method in it. It's called start element. And all it does is print out the name of the element. And then we have a Sax parser. I should back up. Sax is an API for XML parsing that basically is designed to let you chain together a parser and a whole bunch of kind of consumers of the parsing. And so in this case, we just have our simple echo class, and we have our parser, and we tell the parser, OK, go parse this file. And whenever it finds a new element, it's going to call start element and pass it some data, basically saying, hey, here's what I found. I don't care what you do with it. And the echo class prints it out. And you know, to really implement a Sax consumer, you also have to provide a bunch of other methods like end element and a whole bunch of other things. And so the advantage of this is that, you know, in this case, oh, I forgot to change my slide. The observer here is XML Sax, that should say echo. It doesn't know anything about how the parser works. It doesn't have to know the parser's API. And the parser doesn't really have to know anything about the details of XML Sax echo. It just knows that it has a specific API. It doesn't have to know what it's actually doing with the data it finds. And so the example, the kind of benefit of this is we can just mix and match things. So we can have different parsers, and we can have different observers. So XML, these are real CPN modules. XML Sax is a parser that generates kind of standard Sax events. And XML Sax Writer is an observer. And what that does is actually write out XML to a handle or to a file of some sort. So the kind of key use for this particular pattern is basically it lets you decouple parts of a system. And you might see terms like producer consumer or publish subscribe. And basically it really lets you make a kind of system more pluggable. Like I said, I really like parsers as a good example of this. So basically, you know, you can substitute different parsers. You can have different things done with the parsing output. And the two sides just don't have to know that much about it. They have a fixed API between them. So this is kind of this is a pattern that's described in the patterns book. I think it's kind of weird. It's basically like a high-level API on top of a low-level API. And it's designed to kind of simplify usage of a set of classes. So here's an example. Let's say we have a compiler and some sort of that returns bytecode and a bytecode executor. And without a facade, we have a bunch of code. We make a new compiler. We tell it to compile. It gives us bytecode. And then we make a new interpreter and ask it to execute the bytecode. And so the idea of facade is that you make a new class, let's call it program runner, and all you do is tell it to run. And it provides a much higher level API. Now, the reason I think this is really weird is this a pattern? Because I just call it good design. If you have a complicated API that requires many steps, and you find yourself typing that over and over again, do you really need to like read the patterns book to tell you that you don't need to repeat this over and over again? Hopefully not. So, sometimes when I was reading the patterns book, I'd just be like, who actually needs this book to tell them to do this? It's, do your job, be a good developer, don't suck, But anyway. So Perl has kind of a bunch of stuff built in that is kind of talked about as patterns in the patterns book. And actually, I think this is one of the things that makes Perl a nice language. That it's you read the patterns book, which was C++ and Smalltalk, and you're just like, God, those languages, they make you work really hard. So Perl has things that are built in, or you can just go on CPAN and get something to do it for you. I'm not sure if this is still really even qualifies as a pattern. At this point, it's just a language feature, which is, again, what MJD talked about in his blog, is that patterns are the things you repeat over and over again. But once you kind of build them in and kind of abstract them enough, it's not really a pattern anymore. So this is one I was thankful I don't have to deal with. It's called Memento. It's this pattern for freezing and storing, freezing and thawing objects. And I was like, oh man, that would be a pain if I had to do this all the time. So you can just use Storable, or about a dozen other modules that do this on CPAN. But Storable is pretty stable, and it's pretty fast, and it works pretty well. And then it also has these hooks built in. If you grep the docs for Storable freeze and Storable thaw, lets you kind of control what data you actually store when you are freezing the object, and then lets you kind of control how it's thawed, which is it's a pretty cool feature. So you don't really need the Memento pattern in Perl. We wouldn't even talk about it as a pattern. We wouldn't say, I'm using the Memento pattern. You'd say, I use Storable. This is another one that makes me thankful that I use Perl. There's this whole pattern described for how to return a list. And I was like, oh my God, I can't even imagine a language that doesn't have this. So in Perl, we have this great thing called, lists, and they're built into the language, and then we have this great thing called for each. And so you can just do that for my color, blah, blah, blah. But apparently in other more painful languages, you actually have to, build a class to do this. But I should qualify that iterators are still useful. We see them, for example, in DBI's API a lot. And in particular in DBI, they're kind of useful because otherwise, if we built an array or a list and just returned it all at once, say it was your query selects, say, 10,000 items from the database, then that all gets jammed into memory. It makes a big fat Perl data structure, and then you iterate over it, which is both slow and memory abusive. So iterators are still useful, but they're kind of optional in Perl, which I like. And then there's this pattern called the Decorator, which is about adding behavior or attributes to an object. There's a great module on CPAN called class trait, which lets you apply traits actually to a single object, which is kind of cool. So you can kind of say, okay, I have a dog, but now I have a talking dog because I'm going to apply the talker trait to my dog, and now my dog can talk. But if I have another dog and I try to call talk on it, it just doesn't work. So this is kind of useful. This is one of those cases where this seems like getting towards the amount of rope where you're starting to really be able to hang yourself with it. So I'd say use with care. But it's still nice that you can do this and do this so simply. I think the example in the patterns book has at least like 4 or 5 classes involved in this. So I guess to summarize, Perl isn't C++ or Java, which I think is one of its great advantages. And some of the patterns in the patterns book are really just workarounds for the horribleness of those languages. Perl also just lets you do more nastiness. But you know, when I read the book, I was just, man, I'm so glad that I used Perl. And one of the things that really struck me reading the patterns book is, you know, every pattern just has at least, you know, 4, 5, 10 classes involved, and it's really complicated. With Perl, you can often get away with less classes, which generally I tend to think that the fewer classes is often a good thing. If you have a kind of amazing profusion of classes, it just gets so complicated. Of course, that's just a huge sweeping generalization, which I'm sure somebody will disagree with me on. You know, patterns are kind of the opposite of dry in many ways, because they're all about repeating yourself over and over. And again, they really, you want this stuff to be invisible. So use CPAN if you can. Write a CPAN module to do it if you can, and upload it and let other people benefit. Or hopefully build it into the language. Perl 6 builds in various things we saw. For example, decorators are completely built into the language. You won't need anything like class trait in Perl 6. And again, see MJD's article. I thought it was really interesting. Highly recommend it. And that's it. Thank you. And are there questions?
質問ある方? Anybody have a question? Comment? Observation? いいですよ。
パールっていうのはこうダイナミックな言語なんで、スタティックな C++ とか Java と違ってやっぱりパターンには使わなくても良いというか、使わなくてもできるようなことがいっぱいあると思うんですけど、その辺はどうでしょうか。ちょっと触れられてたみたいです。
So Perl is a very dynamic language as opposed to C and Java, which are a bit more static. And it seems that the dynamic nature of Perl sort of makes patterns less applicable. What do you think about that?
I totally agree. I mean, I think there's some patterns that are still really useful. For example, like the factory pattern is something I find myself using all the time. And again, there's DBI, which does it. File spec is kind of, it's a very bizarre version of a factory. But yeah, definitely, I think that's a good thing that, again, these patterns are solving repeated problems that people found using C++ or Java or whatever. Well, if you see this problem over and over again, and you have to write 4 or 5 classes to solve it every single time, I personally would find that very tedious, and I like the fact that Perl kind of does away with some of the overhead. But on the other hand, Perl has its own things that you repeat over and over. For example, how many times have you written your own little object or kind of class definition library or used one off CPAN? And, that's something that, for example, should be built into the language and, is in Perl 6. So Perl still has I think a long way to go to be kind of an even higher level language.
次はしましょうか。大丈夫です。その通りだとおっしゃるんですけども、でやはりパールの場合ではですね、より簡単 C パンや言語の方に戻すことができるんですね。で C と Java の方ですと、スタティックの部分もありまして、でどうしてもそのクラスを生成することによってパールでダイナミックの部分で、実現する部分を作ってしまおうというところなんです。でやはりそのファクトリーパターンとか、多少使うところは使えるんですけども、やはりそのさっきちょっと言った通りの、C パンのモジュールに作ったり、その言語自体に取り込むっていう体制ではすごく、パターンの機能もすることもあります。で当然パール6の、リリースも、近くなってくるんではないかというところなんですけども、そのパターンも、言語の一部として取り入れていることも見られますので、今後はパールはそのパターンをより言語の一部として扱うことが、望ましいかなというところでした。 あと質問かなり時間ありますので。We have lots of time for lots of questions.
I'll take questions on anything.
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 What is the weather outside?
Well, yeah, I was out earlier, and it was sunny, but a little chilly, but I thought it was pretty nice. Definitely improvement over yesterday. I can't really speak to the causes of the weather, unfortunately. I'd have to do some research.
Anybody? Anything? So, in my various encounters with various people, I used to find people who came out of a C background or a Java background coming to a group of Perl programmers saying, "Why aren't you using design patterns?" What would you say is the best one-liner to reply to that in a professional yet assertive manner?
Oh, professional? I mean, I think it's kind of twofold. Yes, we are. You'll see it in various ways. Like I said, there are definitely patterns that you'll find useful in Perl, and you'll see them used by CPAN modules. And then there's there's plenty of patterns where they're just not necessary. It feels like at least a third of the patterns in the patterns book are really about working around the kind of static nature of Java and C++. And fortunately, we just don't need to do that. I mean, every time I have to use a language where I can't say return a list of items, it just kills me. Where I can't return, where it doesn't basically have destructuring assignment. I'm just like, oh, this is the most painful thing ever. And I never really thought about it when I was using Perl. It's just, oh, it's so handy. But then you go use something else that doesn't have it, and it's just, brutality. So just tell them they'll learn to love Perl.
あと何か。ないようでしたら拍手お願いします。
ありがとうございました。